Lesson 7.1, we're talking about understanding likelihood and probability. So on page 355, we've got Jared that has to choose one of 8 boxes to win a prize. One of the boxes has a big prize, 3 boxes have a medium prize, 3 have smaller prizes, and 1 box is empty. How confident should Jared be whatever box he chooses he will win a prize? So what do you think? Okay, yeah, it's probably pretty confident, right? Because we've got a total of 8 boxes. How many of them have a prize in them? 7. So he's got, and we'll talk more as we go through the lesson, he's got a 7 out of 8 chance that he's going to get a prize. That's a pretty good chance there. Okay, now if you look at the bottom of the page, suppose the empty box is taken out of the game. How confident should Jared be he's going to win a prize? He should be, yes, 100% confident that he's going to win a prize. All he's got to do is pick a box and he wins. Okay, so this is dealing with probability or the chances of something happening. So look at example 1. Alyssa and Cherry spin the pointer to the right and record the color it lands on. Table shows the results after 100 spins. How can Alyssa and Cherry explain their results? So you look at the spinner here, and if you'll notice we have 4 different colors. The colors on our spinner, in this case we could refer to those as outcomes. Outcomes are possible results. Okay? So if you're doing a problem and they say, what are the outcomes? You got to know what that means. So that's the possible results, the possible things that could happen. Okay? If we're rolling a number cube, our number cube might go from 1 to 6, usually is the case. So in that case, our outcomes would be 1, 2, 3, 4, 5, or 6. In this case, our outcomes are different colors. Our blue, red, yellow, and green are different outcomes. Okay? If you'll notice, like the book mentions, those colors are all the same size, aren't they? So is it any more likely that I'm going to get a blue than a yellow, for example? No. Okay, should have the same likelihood as either any of these happening. Okay, so the likelihood of something happening, or the probability, we could say probability is the likelihood of a certain event happening. Probability is the likelihood of a certain event happening. So in this case, we have 4 different options. It's just as likely for one as the other to happen. So each of those has a 1/4 or 25% chance of happening. All right, so if they spun the spinner 100 times, like it said at the beginning, out of the 100 times we would expect probably about 25 out of the 100 to land in each section. Okay, if you do 100 divided by 4 is 25. And if you'll notice from their results are pretty close to that. Okay, it's not probably going to happen exactly 25, 25, 25, 25. But if it's really far off from that, then we've got an issue where, you know, the spinner's not working right or it's rigged somehow. Okay. We look at the try it. How might the probability of the pointer landing on a given color change for the spinner shown at the right? So if we look at this spinner, compare that to the spinner we had. So what's happening here, each color now, instead of having 1 section, now it's got 2 sections. What happened though is not only did we double how many we have of each, let's say blue for example, since it's pointed to the blue, not only did we have 2 blue sections, we've also doubled how many total sections we had. We had 4, now we have 8. So 2 out of 8, we had 1 out of 4, we have 2 out of 8. 2 out of 8 is the same as 1/4. So we actually have the same exact probability of getting a color as we did in the previous example. Does that make sense? Example 2, Carrie will roll a number cube with sides labeled 1 to 6. What is the probability she will roll a 2? Well, we've got 6 sides, 1 through 6. There's only one of those that's a 2, so probability would be 1 out of 6 or 1/6. We can write these as percents as well. 1/6 does not come out real great as a percent. I think it's like 16 2/3, 16.6 repeating percent, something like that. But we can do that also. The deal is we won't always necessarily be using a calculator. And in that case, if we're not using a calculator, obviously you would probably just put it as a 1/6 chance and not worry about what the percent was. If you look at part B, what is the probability she will roll a number less than 7? Well, our numbers on the number cube are 1 through 6 in this case. So less than 7, we've got a 6 out of 6 chance, or 1. Okay, and a lot of times we'll just say a 1, or that's the same as what percent? 100%. Okay, 100% chance. You can say that also when you don't need a calculator to figure that one out. Part C then, what is the probability she will roll a number greater than 6? Well, 6 is the highest number, so there are 0 out of the 6 numbers that are greater than 6. So that's 0 or 0% chance that she's going to get a number greater than 6. So look at the try it. The game piece shown over here has 12 sides labeled 1 to 12. So what is the probability of rolling an 11? So for an 11, we have 1 11 out of 12. So the chance of getting an 11 would be 1/12. Sometimes when you guys do these problems and it talks about the probability of something, probability is such a long word that they have come up with an abbreviation for this. Okay, mathematicians like to abbreviate things a lot of times. So sometimes you might see it like this. If you see a P and then something in parentheses, that means probability of whatever's in the parentheses. Okay, so that would mean probability of the 11, probability of getting an 11 is equal to 1/12. Okay, you look at part B. What is the probability of rolling a number greater than 5? So greater than 5 does not include 5, just greater than 5. So greater than 5, we've got 6, 7, 8, 9, 10, 11, 12. That's a total of 7 out of 12. And again, we could get percents for these as well, but just writing the fractions is good enough for our purposes right now. And then if you look at part C, what is the probability of rolling a number greater than 12? We don't have any numbers that are greater than 12, so that would be a 0 out of 12, which is equal to 0. Or this one you could nail without even thinking about a calculator. That would be a 0% chance. Example 3, Marisol designed a spinner for a game. The spinner is fair if there is an equal chance for the pointer to land on each number. Is the spinner a fair spinner? Okay, so out of that, they kind of told us this information here. We have a fair spinner is the probability of landing on each option is the same. So if you look at this, we've got an A and another A. We've got a B, we've got a C, a D, and an E. Well, what's the problem there? There's two A's, right. We got two A's and only one of the other things. So that is not considered to be a fair spinner because it got a higher chance of getting an A than these other letters here. So if we look at the try it then, they ask if this is a fair spinner. If yes, explain why. If not, describe a change that could make the spinner fair. So this one, obviously, we have more of some than others, so this would not be a fair spinner. So we'd say no, there are different numbers of each color, something to that effect. Okay, and then in order to make this a fair spinner, the easy fix would be that we just change, we'll go ahead and type this up once, we could change the gray to a red. That would be a way to make this a fair spinner. Another option, that's the easiest choice. Another option would be that we could take out a section, make it 9 sections instead of 10, and then we could have 3 of each. 3 blue, 3 red, and 3 gray would be another way. So look at the key concept. There's actually giving us some new information here we haven't looked at yet. Probability is always going to be from 0 to 1. And probability we can write as a ratio, like 1 out of 2. We can write it as a fraction, like 1/2. Or we can write it as a percent, like 50%. So the number line kind of gives us an idea of how likely it is for something to happen. So for example, if we're rolling a number cube and they say what's the probability on a regular number cube that we're going to roll a 7, that would be 0 out of 6 or 0 chance. That's impossible. Okay, so if something's not going to happen, it's impossible, and that means the chance is 0 or 0%. If something's certain, like it's guaranteed, right? If we roll a number cube, regular number cube, and it's that's going to be less than 7, all the numbers on the regular number cube are less than 7, so that's certain is 1 or 100%. Okay, most things are somewhere in between. Okay, usually, like for example, if you watch the weather, usually they don't necessarily just say a 0% chance of rain or a 100% chance of rain. Okay, usually it is somewhere in the middle there. And so what we can do is talk about, likely or unlikely. Well, if it's over 50%, but less than 100%, that's considered to be likely. And then if it's more than 0 but less than 50%, then it's considered to be unlikely. And then this 1/2, then you might say, well, you didn't talk about the half. That is considered equally likely. It's an equal chance. Okay, now if they say 50% chance of rain, it seems like it generally tends to rain on days that they say that, but technically is equally likely as unlikely if we got a 50% chance. So look at the do you know how. Allie is going to select a card from a group of cards shown. Complete the statement. So number 4, probability Allie will select a card labeled 3. If you look at the cards, we've got 2 of the cards that are 3s, so that's 2 out of 10. Now 2 out of 10. So if you remember, a percent is a number out of 100. So one thing we could do, multiply both of these by 10. That'd be 20 out of 100, which would be 20%. The other thing in general that you can always do is divide the numerator by the denominator. So 2 divided by 10, you get 0.2, and then you could just move your decimal 2 spots to the right and add a 0. Number 5, because the probability each number will be selected is not blank, the group of cards is not fair. So that would be not equal. We could say not fair, but that's being kind of redundant. Because it's not fair, then it's not fair. So not equal would be our better answer for this problem. Alright, and then number 6, it is blank that Allie will select a card labeled with a number less than 6. So that would be certain because all of the numbers are less than 6. And number 7, it is blank that Allie will select a card labeled 4. And if we look at this, there are none of them that have a 4, so that would be impossible. So workbook page 83, number 1. Random selection will be made from a bag containing different colored discs. Of the 25 discs in the bag, 5 are yellow. So here's that notation again, that probability of yellow equals 5 out of 25. So part A, the probability a yellow disc will be selected is 5 out of 25, and we can actually reduce both of those by 5, would reduce our fraction down to 1/5. Good. So part B, complete the sentence to describe the likelihood of randomly selecting yellow disc. It is blank that a yellow disc will be randomly selected from the bag. So this actually would be unlikely, and the reason we know that is because 1/2 is our cutoff. If it's more than half, then it's likely. If it's less than half, it's unlikely by their considerations. Okay. Now, if they told me I had a 1/5 chance of winning the lottery, I might consider that to be likely. But technically, there's a better chance of it not happening. By the way, the chances of it happening is nowhere near that. So, anyway, this would be unlikely then. Number 4, a bag contains 80 colored tokens. Of all the tokens in the bag, 25 are black and 5/16 are red. Find in percent form the probability of choosing a black token and the probability of choosing a red token from this bag. So the probability of a black token, it tells us that there are 25 out of 80. So that's 25/80ths, and you can reduce that if you want to. Since it says in percent form, that's not really going to make a big difference here, but if you reduce that, that would be 5/16. And then percent form, what you can do is just divide 5 by 16, or from the beginning we could have divided 25 by 80. And we'll get 3,125 10,000ths, 0.3125. That's as a decimal. To change to percent, we can just move the decimal 2 spots to the right. So that would be a 31.25% chance of getting a black token. And similar idea for a red token. Now for a red token, they already gave us a fraction, which was 5/16. Well, since we reduced this, that should look familiar because our first fraction reduced to 5/16. So probability of a red would also be 31.25%. So then part B, compare the likelihood of choosing a black token to that of choosing a red token. We could say they are the same. We have an equal chance of getting a black as a red. Number 5 asks, is the spinner shown a fair spinner? Explain why or why not. So we can see different sections. Obviously the green is bigger sections than anything else, and we've got all kinds of different stuff happening here. So we could say no. We could say there's different chance of each color being spun. Number 6, Angela is using a number cube for a game with faces labeled 1, 2, 3, 4, 5, and 6. Is this number cube fair? Explain why or why not. This one would be fair because there's equal chances of getting each of the different outcomes. Look at number 8. Greg has a bag that contains 25 colored tiles. Of all the tiles in the bag, 10 are blue. Another bag contains 250 colored tiles and 75 are blue. From which bag is Greg less likely to pick a blue tile? So the first one we've got 10 out of 25. Second one we got 75 out of 250. One way we could figure this out, we could divide these, figure out what the percents. So 10 out of 25, if you divide that, is 4/10, which means 40% if we move our decimal over 2 spots. 75 out of 250, if you divide that out, you get 3/10, which would mean a 30% chance. So less likely then would be the second bag. Another way we could figure that out would be, since our denominators, we got a 25 and a 250, if you multiply 25 by 10, you get 250. So that'd be equivalent to 100 out of 250, which is more than 75 out of 250. So just depends on the denominators. If they work well together, you can get a common denominator. Otherwise, you can just divide them out and figure out the percentages. Number 9, Hector made some observations about the numbered cards before his friend turned them face down and rearranged them in a different order without Hector looking. Which of Hector's statements is true? If Hector randomly selects one face down card, select all that apply. So probability Hector will select a card numbered 1 is 1/8. And if you look, 1 out of our 8 cards here is a 1. So that statement would be true. Probability Hector will select an odd numbered card is greater than 50%. So odd numbered cards, we've got a 1, a 3, and a 5. That's 4 out of 8. That's exactly 50%. So not greater than 50%. It is certain Hector will select a card with a label that is greater than 0. We cannot say greater than 0 because we have 2 zeros, so that doesn't work. It is impossible for Hector to select a card labeled 2. That would be true. None of them have 2s. And it is more likely Hector will select a card labeled 0 than a card labeled 3. If you look, there are 2 zeros and 2 3s, so equal chance, not more likely for one than the other. So that would be it for that one. So this gives you an idea about likelihood and probability.